How does creating an interactive itinerary in Scratch enhance computational thinking and coding? To answer this question, let's first look at the problem in more detail. Students must create an interactive itinerary that allows the viewer to make a choice about what activities to undertake in a selected Asian country. To solve this problem, students must formulate the problem so that it can be solved using the power of computers. To do so, computational thinking must be applied. A computational thinker collects data and analyzes it to understand the problem. They then decompose the problem, or break it down, into simpler problems. Instead of solving only that problem, they must look for patterns, remove details, and abstract so that they can solve all problems of that type. They then define the steps to solve the problem, the algorithm, and if possible, build a model to stimulate, test, and debug the solution. In our activity, the students apply computational thinking as they use their knowledge of Asian countries, developed in their geography unit, to understand the problem. They then decompose the problem into parts as they break down the choices an individual would make about an itinerary through the construction of a tree diagram. The tree diagram also requires students to apply algorithmic thinking as they use branching to sequence steps that enable an individual to make choices about an itinerary for their chosen country. This algorithmic thinking is further developed when the students convert their tree diagram into flowcharts, then into coding language, and then into the Scratch software. Before using Scratch to code, the teacher first models how if statements may be utilized in Scratch to indicate a choice of itinerary for the country of Japan, so that the students can find patterns, remove details, and abstract the process for an interactive itinerary in their chosen country. The students use Scratch to implement their solution and can easily test and debug the solution in the process due to the highly tinkerable nature of the program. Throughout the learning sequence, students also have the opportunity to develop their knowledge of coding through the introduction of flowcharts, coding blocks, if statements, and the Scratch programming language. However, computational thinking is not just applied to coding. It can also be applied to other subject areas and a range of everyday contexts. For example, students may apply computational thinking in mathematics when solving written problems, as they decompose the problem into simpler problems. They identify the patterns within the problem, abstracting all relevant information to solve the problem. They then check their answer by applying the solution into a mathematical function and debug any problems with the solution. In a similar way, students may apply computational thinking to everyday contexts, such as figuring out what time to get up in the morning in order to get to school on time. Teaching students to create with technology and use computational thinking to solve problems is crucial to their success in our digital world. As teachers, we should ensure that they are able to move beyond the mere consumption of technology and into creation and problem solving.